Hey guys, welcome back. Today we are going to start a lesson on trapezoids and kites, and we will focus in today on the trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so here is an example of a trapezoid. There's a pair of parallel sides and only one pair. No more, no less. The bases of a trapezoid are the two parallel sides. So there are two bases. There's a base here and a base here, the two parallel sides. Base angles of a trapezoid are either pair of angles that share a base. So there's a base angle pair here. There's also a base angle pair here. So either pair that shares a side. So these two are a pair of base angles, and these two are a pair of base angles. The legs of a trapezoid are the two non-parallel sides. So here is a leg, and here is a leg. So two bases that are parallel and two legs that are not parallel. So with that information in mind, we want to show that CDEF is a trapezoid. So if this is going to be a trapezoid, there's one pair of parallel sides, which will have the same slope, and the other sides will have different slopes. So it looks like DE and CF will be the parallel sides, so let's find their slopes. So the slope of segment DE, slope is rise over run, that's change in y over change in x. So the y's are 3 minus 4, and the x's are 1 minus 4. So that's negative 1 over negative 3, which simplifies to 1/3. Now the side that looks parallel, CF, should have the same slope. So the slope of segment CF, 0 minus 2 over 0 minus 6. Okay, so that is negative 2 over negative 6. Negative over negative is positive. And 2 over 6 simplifies to 1 over 3. These two have the same slope, so they are parallel to each other. Okay, so we have these parallel, but in order to be a trapezoid, it has to be exactly one pair of parallel sides. So we need to show that these two sides are indeed not parallel. So the slope of segment CD, 0 minus 3 over 0 minus 1. Okay, so that's negative 3 over negative 1, so the slope is 3. And then the slope of segment EF. The slope of segment EF is found by 4 minus 2 over 4 minus 6. So that would be 2 over negative 2, which is negative 1. These are not the same. So this is a trapezoid because there is exactly one pair of parallel sides. What if point E is moved to 7, 5? So right now it's at 4, 4, so 5, 6, 7, and then 5. So point E is now moved here. What kind of quadrilateral are we looking at here? Okay, so let's find the slope of the new EF. Okay, so that would be 5 minus 2 over 7 minus 6. And that is 3 over 1, which is 3. So now these two are parallel. So we now have two pairs of parallel sides, and that makes this a parallelogram. Okay, so now let's talk about an isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. So an isosceles trapezoid has the one pair of parallel sides, and then these legs are congruent to each other. Okay, so let's talk about some other properties of isosceles trapezoids. So isosceles trapezoid theorems. If a trapezoid is isosceles, then each pair of base angles is congruent. Okay, so in this isosceles trapezoid, these two base angles are congruent to each other, and these two base angles are congruent to each other. So if trapezoid ABCD is isosceles, then angle B is congruent to angle C, and angle A is congruent to angle D. Both pairs of base angles will be congruent. Now the converse is also true. If you see a trapezoid in which there is a pair of congruent base angles, then that trapezoid is an isosceles trapezoid. So if angle A is congruent to angle D, as shown here, then the trapezoid ABCD is an isosceles trapezoid. Or, if you would know that angle B is congruent to angle C, then that would also be enough to know that this is isosceles. So if you see at least one pair of base angles congruent, you know that this trapezoid is isosceles. A trapezoid is isosceles if and only if its diagonals are congruent. So if you see a trapezoid in which the diagonals are congruent, then you know that it's an isosceles trapezoid. And with that intersection, here's how we can show that these are congruent. These two parts here would match each other, and these here would match each other. And that makes BD and CA congruent diagonals. Okay, so this trapezoid ABCD is isosceles if and only if segment AC is congruent to segment BD. The diagonals are congruent. A shelf fitting into a cupboard in the corner of a kitchen is in the shape of an isosceles trapezoid. Find the measures of angles N, L, and M. N will be a nice easy one. So these legs are congruent. That means these base angles are congruent. So we've got 50 degrees here. So the measure of angle N is 50 degrees. Okay, now because these are parallel, consecutive interior angles are supplementary, so these will add up to 180 degrees, and so will these. It does not work this way. These will be congruent, and these are congruent. This way, these will be supplementary. 180 minus 50 is 130. So the measure of angle L and the measure of angle M are equal to each other, and they are 130 degrees. Okay, now in this one, find the measures of angles CA and D, and because of these tick marks here on the legs, I have congruent legs, which means I have congruent base angle pairs. So the measure of angle C is 135 degrees. Okay, then we can do 180 minus 135, and that is 45, which means we've got 45 degrees right here. The measure of angle A, which is congruent to angle D, so the measure of angle A equals the measure of angle D. Those are both 45 degrees. And we will stop there. In our next video, we will talk about the mid-segment of a trapezoid.